is lesson 3.5. We're adding and subtracting like fractions, like meaning same denominator. Denominators are super important when it comes to adding and subtracting fractions. You're lucky today you don't have to change anything because everything is going to have the same denominator for you. So our job is just to worry about making sure we're adding and subtracting correctly. So first thing we're going to talk about is, like I said, today's same denominator. All you're doing is you're worrying about the numerator. Make sure that your answer is written in fraction format, which is this one, and then make sure that you're reducing as much as you can. Now, when you reduce, when you're adding and subtracting, it has to be done at the end. When we were multiplying and dividing, you could reduce inside the problem before you got an answer. But today and tomorrow, everything has to be done at the end. All right, so let's get started. If I look at 5/9 plus 2/9, you all know by now, you should, that if we're adding fractions or subtracting fractions, we do not touch the denominator. So this should be 9, and then I only worry about the numerators. 5 plus 2 would be 7. Okay, same thing over here. I have 10/15 minus 4/15. Denominators stay the same. I'm just worrying about my numerator. So this would be 6. Then I have to make sure it's reduced fully. I know this can be reduced by 3. So it'd be 2/5 would be my answer there. So really, I'm not too worried about this. One thing I'm concerned about, though, are mixed numbers. And I think this is something we need to talk about and take a little closer attention to. Now, last year, I taught you 2 ways to do this, and I'm going to do the same thing again. 2 ways. Okay, this is going to be number 1, and this is going to be number 2 over here. Number 1 way, and I believe most of you did this last year. I'm about 100% sure most of you did this last year, where you just wrote them on top of each other, and you added them this way. So you would just worry about the fractions. 5 plus 1 would be 6/8. 6 plus 1 would be 7. Now make sure this is reduced. It'd be 7. Let's see, I can reduce by 2. It would be 3/4. Okay, that's one way. It seems really simple, a lot less work. Another way is improper fraction, changing everything to improper fractions. Actually, number 2 way, improper fractions, comes in handy when you're talking negative numbers. Okay, so this way you might still need to know, but it's actually really more handy when something is negative inside of a problem. This one is not negative. So let's see. 8 times 6 is 48. 48 plus 5, I think, is 53. This one would be 8 times 1, would be 9/8. Okay, so this would be 62/8. Okay, now changing this to a mixed number. Okay, and this would be my numerator. This is my denominator. So it'd be 7 and 6/8, which are reduced to 7 and 3/4, just like what we had. The reason why the improper fraction one is easier with a negative is because if this was a whole negative, then you would just look at your numerators up here and decide. It's almost too hard to think about one being positive and one being negative. This way, it does not work very well. Doesn't work with negatives well. And I'll show you some examples of this in a second. Okay, so this number 1 doesn't work with negative as well, but the other way does. So it kind of just depends what you have going on in your problem. I want to give you, we're going to talk about some more of these. Okay, so here's an example. I'm going to give you an addition example. So if I have 5 and 1/6 plus 4 and, actually I'm going to change that. I'm just going to make it a little higher. 4/6 plus 4 and 5/6. Okay, if you're going to add them, just watch. Okay, if you're going to do it this way, notice that 4 plus 5 is going to be 9/6 on this side, and this you're going to have 9. Now here's the problem. You cannot have a mixed number or improper fraction inside of a mixed number. So our job is we're going to make this a mixed number. It's going to be 1 and 3/6, which would be just 1.5. Okay, so then we're going to take this, and we're going to take this, and we're going to put them together. The reason why we can't have an improper fraction there is because there's a hole in there somewhere. So it doesn't make sense to have a whole number, 9, and then a hole inside of a fraction. So we're going to put all of our holes with the whole numbers. So this would be 10.5. And that's how we do it that way. Okay. Another thing I need to talk to you about is subtraction. So let's do like 6 and 1/6 minus 2 and 4/6. Okay, so 6 and 1/6. minus 2, and 4, 6. Now, if you look at this, I can't take 1 minus 4. I can't do it. So I have to borrow or regroup or whatever you people call it. So this is going to become a 5. And then I'm going to take that 1 and I'm going to split it up into fraction pieces over here. I know it's going to become 6 over 6. And the reason I know that is because the denominator right here. So really now I have 7, 6. So what this is, it says 5 and 7, 6. What I just did is I took some a whole and I split it into fraction pieces. Now I can do my addition here, or my subtraction. So 4 minus 7 minus 4 is 3, and this is 6. And then 5 minus 2 is 3, so this would be 3 and a half after I'm regrouping. If you have questions about regrouping, mark that in your notebook so we can talk about it tomorrow. Okay. Negatives is another thing we need to worry about. Keep, change, change is a thing with negative numbers. So remember when you use keep, change, change, if you had a negative and a subtraction, or you had a subtraction and the last number was bigger than your first number. And this is an example right here. So I know 20 is going to stay the same, but look at, I have 9 minus 13. Well, this is a keep, change, change thing. If I wanted it to be, keep, change, change is how it would look. And the 9 plus negative 13 would be negative 4, and I can reduce to negative 1/5. The thing about negative fractions is we're just dealing with numerators. Remember, denominators always stay the same. So what happens is your negatives actually float up to your numerators, and that's where you have to deal with them. So for an example, this would be just 5, and then it become negative 2 plus negative 4, which would be negative 6, and then change it to a mixed number. That's what it would look like. So a few more negative examples, let's talk about those. So this is really what it would look like. It'd have parentheses around it like this. So this is 3/5 minus 4/5, minus negative 4/5, my bad. This is a keep, change, change one. Keep, change, change. So this would be kept, this would be changed, this would be changed. So this in reality would be 5 7/5, which should reduce to a mixed number as 1 and 2/5. This is not a keep, change, change because it doesn't have a subtraction in it. Remember, you have to have both things. So this one would look like 6, and then negative 4 plus negative 2 would be negative 2, and then reduced to 1 and a third, I guess I should say. So careful with the negatives. I'm going to do one more negative one with you. Probably two. I'm going to do one with whole numbers and one with just some small fractions. So if I have negative 5 sevenths minus 2 sevenths, this is keep, change, change also. I have subtraction and a negative. So this is going to be, first one's going to be kept. This is going to be changed. This is going to be changed. Now I have 7 as a numerator or a denominator, and then I have negative 5 plus negative 2, which would be negative 7. Reducing it would be negative 1 over 1 or just negative 1. That works fine. So careful with key, change, change because it'll happen. So here's another example. If I have negative 6 and a 6 plus, I don't know, 3 and 2 6. Okay. Let me show you what I mean by improper fraction would probably work the best. So 6 times 6 is 36, so this would be negative 37 over 6. This side would be 18, 19, 20 over 6. Now look, there's no guessing about what has to be done if you have to add or subtract or whatever. It'll literally tell you right in the problem what has to happen. It says negative 37 plus 20. Well, I know negative 37 plus 20 is going to be negative 17 over 6. And then you make your improper fraction or your mixed number. Let's see, that's going to be 12. I think that's what it's going to be. 2 and 5, 6. And then it's a negative because that 17 is a negative number. If you didn't do it that way, and if you wanted to do it the way 1, like I talked about before, you'd have to say, okay, well, I have negative 6, so that's going to be 6 cats. I have 3 dogs. I can make 3 ordered pairs. So really, you take 6 and 1 6 minus 3 and 2 6. So like this. I'll just show you quick. We actually would need the negative. 6 and 1 6 minus 3 and 2 6. Okay, you're going to have to regroup. It'll be a 5. This will be 7 6. It'll be 5 6. 5 minus 3 is 2. Well, then you have to say, okay, which one's bigger? Well, which one has the negative is going to be bigger, so it's going to be negative 2 and 5 6. I know I went through that a little quick, so if you want some clarification on that tomorrow, it'd be a really good idea to ask a question. But like I said, it's a really good idea if you have a negative number and a positive number and you're putting them together, putting them in improper fractions is kind of foolproof because it tells you exactly what you need to do in your problem. There's no guessing if you have to add or subtract. There's no guessing if you have a negative answer. Like, it's going to tell you right there in that problem. So that's really, really a foolproof way to do it if you have a negative and a positive together when you're adding or subtracting. So if you have any questions, let me know. Thank you, thank you, thank you for watching, and I will see you tomorrow.